the co-founders of the community are Sienna Williams and Chidima Nyugu. So initially, the way the community was, Chidima had her own community that was based in Nigeria, and Sienna had her own community that was also based in Ghana. And so they came together and decided that they wanted to put the two communities together so that there would be like an umbrella for women in geospatial, like women in GIS in Africa. So, instead of having two separate communities, they wanted to then bring the platform together, their communities together, to have like one joint community for women who are in Africa and who are in the GIS industry. And so that was how the community came to be. So when they started, they had 41 members from Nigeria, and then they also had from one member from Burkina Faso, and then 11 members from Ghana. But now, we have like over 400 members in over 30 countries, and yeah, we're becoming more global. So our community is not only limited to women who are in Africa. Our community is for any woman, whether in Africa or outside of Africa, who has an African heritage. So you're welcome to join our community. Yeah, we have our members in Nigeria, Kenya, Ghana, South Africa, and other countries around Africa. So the reason why they wanted to create the community, like I said initially, was just to create a platform for women to be able to get role models and connect, and also solve some of the professional problems that we have in the GIS industry in Africa. Yeah, they were also looking to also give job information, and then also like encourage women to take part in mentorship and get mentored. So far, the way we've contributed on solving these problems that we saw is true. We've had a lot of webinars. We've had webinars for the International Women's Day. We've also had the webinar. We also joined the special interest group meeting for the 2020 Israel Visa Conference, and also we participated in the North Star Overcoming Week. We've also collaborated with some organizations, and we've also had our own internal webinars, like the one you're joining on. It's one of the webinars we collaborated with the Women in Geospatial Plus. Yeah, we've also had our speakers. We've also given our speakers platform to also speak at some of the events that we've been invited to. Yeah, we've also collaborated with a lot of organizations, as you can see on the screen. So we also have a mentorship program where we try to connect women students, geospatial students, and early career professionals with women who are already in the industry and they've gained their ground in the industry. And also, so far we are in our third cohort, and our mentorship program is run twice in a year. So we have from June to November, and from October till March. So right now we're in the third cohort, and the third cohort is going to to an end by the end of next month, and then we should have our next cohort up and running very soon. Yeah, so far we've seen that with our community, we've been able to motivate women to put themselves out there and to gain more skills in their profession as a GIS professional. So if you'd like to be part of our community, you can join our WhatsApp platform or our Slack channel. You can also follow us on LinkedIn and Twitter, and also check out our website at africanwomeningis.org to learn more about the community. And thank you so much, Sharon.
Thank you so much, Omonwola, for that presentation on African Women in GIS. I've shared the links to African Women in GIS website as well as Women in Geospatial website. So before we go to the main session for the day, that is spatial analysis in Python, I'm sorry, I didn't introduce those who were involved in planning for this webinar. With me, we have Safinas Mubarak from Egypt, Cairo, who is the African Women in GIS North African Ambassador. We also have Nasilele Amatende from Zambia, who we work with in the Women in Geospatial Plus Sub-Saharan Africa region. And Yeah, those are the only ones who have joined today. And the other days that are coming, we're going to meet other people who are planning for this webinar, who are going to join to lead the sessions. Yeah, so we are going to go straight to the talk. And we have our speaker, Sam Wanjohi, who is ready. Yeah, Sam, you can share your screen. Think you have the screen right. Yeah, and before we start, just some point to note. Please let's use the chat for questions instead of raising your hands. So let's all your questions, please post them in the chat, and then we will we'll read them out to the speaker after the session, after the speaker is done. Yeah, so our speaker today on spatial analysis in Python is Samuel Wanjohi from Kenya. Sam is has a 7 years experience in the GeoIT sector, and he finds passion in utilizing GIS to solve problems and develop working spatial solutions for clients globally. Sam also runs Life in GIS blog, where he shares his ideas and knowledge with other users in the geospatial industry. Sam, please go ahead. Welcome.
Okay, thank you very much, Sharon. I hope you can hear me.
Yes, we can hear you, Sam.
Yes. Today we are blessed with the rains. It rained so heavily. So I'll try to cover my topics before it starts raining again. So my name is Wanjohi Kibwe, or Sam Wanjohi. I'm based in Nairobi, Kenya, and I deal with the development of GIS systems, mostly on the web, but also desktop. I also run training sessions on GIS development, software use, mobile data collection, and all that pertains the GIS spectrum within any organization. So I work with both government, non-government institutions, private sector, and also NGOs. And having covered different countries in Africa, so at least I'm well conversant with some of the landscapes and some of the architectures that are out there within the industry. So I'll just share my screen straight away. So today I'm covering spatial analysis in Python, which is basically my main language that I've been using for these years. And in this topic, or in this, I hope everyone can see my screen.
Yes, Sam, I can see your screen, but on your screen, I can see African women in GIS. I don't see your slides.
Women, oh, okay. Maybe I've shared the wrong screen. Let me share again.
Okay.
All right. Do you see my PPT now?
Great.
All right. So I work with an organization called AWiGIS Consulting. That's basically my organization. So here we do deliver those services, as I have said before. I also run a blog on Life in GIS, whereby I started a long time ago while I was a student at the university, where we share materials, tutorials, and also information based on the happenings within the industry. And we basically invite guest writers or guest authors to publish articles on this platform, provided it is based within the geospatial sector. So I'll go straight ahead. But before that, I think I'm honored to be among the presenters in this session. So I'm doing this passionately. All right, so spatial analysis in Python, this was my topic today. And I want to just cover some things briefly. I'm not a very good fan of presentations, the slides. So I want us to begin with a simple concept of the topic today is spatial analysis. So I know maybe we are a mix of GIS users and non-GIS users. So probably there are those people who are seeing this for the first time. But basically, the topic talks about analysis of data which has location. information or location aspects or attributes. And then we try to look at how you can work with this data on a platform or language called Python. So Python is quite popular. Maybe you've heard it, but we'll dive into details to see what it really entails and what it's being used for within the GIS industry. So I'll begin with the simple part of what basically is Python. So of course, for those who've been, I know most of us have tried coding or have tried to develop solutions. So you've been hearing of maybe C#, C++, C, R for statistics. So Python is just one of the programming languages out there. And as it says, there's the concept within the industry whereby people think it's one of the easiest languages to learn. And because of its use, and at the moment, even recently in October, I think it was on Monday 4th, they just released a new version, which is 3.10. And you can see that being popular, there's a lot of development around it. So there's so much that is coming in on the platform or on the language, which someone can leverage to even maybe within the GIS industry or even any other related industry. So being popular, we have some ideas or some issues as to why we've seen Python grow to be popular. And of course, the first thing they say is, of course, the learning curve is a bit easy. So I'm talking about easy learning about a programming language. There are those who've maybe tried it. They say maybe some other languages are a bit hard to start. And it's easy. The syntax, like you can see on this, the image here, like printing something fun. It's just straightforward. It's like you tell them print and it does that. So so this is just a sneak peek. There's so much involved, and there's also it's open source, meaning if you're on iOS, you're on Linux like me, you're on a Windows platform, you'll be able to use it. And of course, there's a very huge community around this language. That's why you see like every 3 months, they're coming up with new versions and new updates on the language. And of course, one thing I love about it is the issue of packages or third-party modules, which basically plug in into what you need to achieve. So if today you decided that you want to build a website, a music website, for example, you'll know that you require maybe a streaming service, you require something like subscription, something to manage viewers, something to manage comments. So Python gives you all these packages that out of the box that you can just leverage, and you have your solution up and running in a short period. With that said, so we have its applications, and as you can see, I've measured on 4 parts, but of course it has more applications. But where Python really wins when it comes to the web and data analysis. So on the web part, probably you've used Instagram, you've used YouTube, you've used Facebook, you've used all those big platforms that I know each one of us is used. They are all based on Python. And you can see that they're basically running one of the best platforms on the internet. So it's very well versed when it comes to developing the backends meaning the administrative portals, the APIs that run various tasks. And of course, within that sector, Python has a number of frameworks that you can use on the web development. And the most popular is Django. For us, those in GIS, of course, you focus on a module called Django, which basically is the Spatial extension of the Django framework. Then you have Flask, you have Web2Py. There are so many. So I just highlighted a few. The second one is scripting. So ever heard of someone tell you that I got all the data about probably schools in Kenya or maybe a certain topic? So you're able to do what we call like crawling, web crawling. You can write some scripts that basically will get to the internet. You say that I want you to scroll a certain website, maybe google.com, and it will be able to give you that information. You'll be able to use to download files, to download text, and also you can check for various information. Like, for For example, emails. You want to check for certain phrases within emails. So you can do that with Python very easily. And of course, at the end of the day, it's all about automation. Then we have that one, which is basically data analysis. This is a very advancing topic at the moment. So everyone is going to data analysis, data science, machine learning, AI, and all that. So Python has become one of the best languages on that frontier. And of course, you've seen so many tools, so many packages coming out that can be plugged into the Python, and it can ensure that you develop solutions that are basically usable, scalable, and also reliable to the users. And then, of course, the fourth one that I focused on was basically software testing. So we have what we call testers. You've developed an application, you want someone to test. They can basically come up with bug tracking or maybe tracking the progress of execution of various processes within the software. And you're able to monitor that, and maybe you can give a review, say that this part needs this change, or this component needs these updates that it can be used. Okay, so for those who have questions, maybe as Sharon said, you can put them on the chat. I'll address them once I'm done with the PPT. Okay, so we have the various ecosystems, and this is not for Python only, even for GIS. So I'm focusing on stuff on GIS or maybe the geographic information systems. So we have the three frontiers, or basically the three components, which is basically the web, the desktop, and the mobile. So when you're a developer, or when you want to start your developing career, you want to first of all decide, do I need to be on the web? Do I need to go mobile? Or do I need to go to the desktop? So you can juggle between different ecosystems. So for example, for me, I do desktop and web. I don't do mobile. Another person will probably consider web and mobile. So it depends on what you do. So the language is one. So if you're good at it on the desktop frontier, it means that you can also do well within the web frontier. Nowadays, things are a bit easier because of the issues of frameworks and a lot of tutorials, a lot of materials on various topics. And these, you can actually decide, if I want to go to web, then this is probably the language that I'll pick. These are the frameworks I want to use, and these are the libraries that I want to utilize. So for desktop and all that. So for Python is very good for the first two. It's growing fast within the mobile component. There are a number of frameworks and platforms that have come up in the, let me say, the last 3 years, where now they want to focus more on mobile development. So it means soon, maybe, or some of the applications you're currently using, such as Spotify, they are developed on Python. Okay. So just to summarize it, we of course know who developed Python. For those who don't know, this guy called Van. And Van has a very good quote whereby he describes what Python does and why it's preferred, and basically why it has become popular. So this quote was a long time ago, but basically it has come to be. And the quote that he mentions here basically describes what's there at the moment. So Python being the most popular language, and also it's easy to learn, and everything has that message has been passed to the communities or to the users or to the developers. And at the end of the day, people have come to resonate with it, that they've been able to use the platform. Okay, so that's it for Python. So let's know what's spatial analysis. So for spatial analysis, this is a bit wide, but I want to cover it in terms of component by component. So just for us to understand. So basically, when we talk about spatial analysis, in a nutshell, we are talking about analysis in considering location. So maybe you want to think of which routes are favorable to drive, probably on a weekend, compared to the to weekdays, which hospital is near my home, which probably which route connects my country to this other country. So there are so many questions that you can ask yourselves, and all these questions, if you think of them, they have what we call the location aspect. So everything, we usually say everything is happening somewhere. So at least that somewhere has coordinates, meaning that somewhere can be referenced on the ground, and you can actually move or travel to that location and find out what happened on that scenario. So taking this data, analyzing it, coming up with decisions or solutions or outputs, and you are focusing on what we call the location-oriented issues. You are able to solve puzzles, you are able to solve mysteries, and you're able to solve problems that are basically located in a certain place. So when you talk about spatial analysis, it can be wide, and depending on how you want to take it, there are those people who are technical who will talk in terms of tools. There are those people who are probably juggle between technical. They are not very technical. You'll find them talking about the applications or the outputs that this thing brings. So it all depends on where you are, but basically spatial analysis can be applied basically on any of the sectors we have around, be it logistics, be it supplies, be it transportation, be it public safety, be it healthcare, emergency responses. All these are places where you can apply spatial analysis. So the goal of spatial analysis is, of course, coming up with results or interpreting situations to derive decisions or insights that you can use for a certain sector or for a certain application. So for example, if you're analyzing population growth within a city, at the end of the day, the insight that you'll get is that there's a certain area where there's a higher population growth compared to another. So if there are things that we need to focus on, issues like schools, hospitals, roads, and all that, they need to be located in that location. So your issue was analyzing population growth. Your insights was coming up with new facilities in that zone, but your results will be the applications or development or construction of these facilities or amenities that you think should be put in place in that location. So that's the whole concept of spatial analysis. And we usually talk of the power of where. So basically the power of location, and everything. Now that everything is happening somewhere, it means you can turn any data you have into location data and use it or carry out spatial analysis on your own. So there are 5 steps into spatial analysis, and this is just a concept or an illustration of how we go through these processes. And the first step, you need to ask yourself, what issue do I need to address, or what problem do we have? Do we have overpopulation? Do we have underpopulation? Do we have congestion, traffic in our cities? So you need to ask yourself the question. And then once you know the question, you are able to identify what we call like formulate a hypothesis. So you're able to ask yourself, if I need to understand about traffic in this city, what do I need to capture? Yeah, maybe I need to know the number of cars coming into the city, the number of roads that are there, the type of roads, any activity happening on that road. Is there construction? Is there demolitions? We need to ask those questions. And then once we understand the question, you're able to analyze the situation. So once you analyze the situation, you've gotten all this data, you've known what you need to do. You now identify, or you come up with what we call like a tool set. You know that I need to use this tool, I need to apply this method, I need to apply that process, so that I can analyze and come up with an output that basically will guide me or will allow me to understand the situation. So you're moving from a situation of unknown to a known situation. So the third step is usually to interpret the result. So you've analyzed you've come up with the tools, you've known which tools to use, you've come up with models, you've computed your data and everything, then you get the results. So are you able to interpret these results? Even if it was something like a marketing strategy, for example, are you able to interpret the data? Why are we getting higher population growths in the slums? Why are you getting higher population growths in areas where are near factories? So you need to interpret those questions. You need to get or to identify patterns, yeah, things like what we call relationships. So we have what we call spatial relationships, and these spatial relationships is basically based on a relationship based on location. How close is this school to a hospital? How close is this hospital to a road? So all those, you need to understand them. And then the fourth part is decide. So you've known that all schools that are near roads have higher population of students. Then what do we need to do? Yeah, do we need to construct more schools? Do we need to add classes into these schools? Do we need to add the teachers? Do we need to add? So there are those questions that you need to decide what to do because you've already got the insights. And then after that is then the last step is basically you share the results. And by sharing the results, we mean you're able to communicate to your teams, to your management, to the public, yeah, to agencies of what your output was and what the decision has to be carried out. So you often hear of government say that this year we estimate that we'll produce a certain number of bags of maize, for example. Let me talk about Kenya. So this year we are producing probably 30 million bags of maize. So that data is not just, someone does not just wake up one day and say, let's communicate this number. There's a lot of analysis, computations that's been done so that they can arrive to that situation. And then of course the government can decide whether they will import more maize or they will hold more maize or they store it, or there are a lot of those decisions. They are informed by a certain process. And that process, in most cases, you find the spatial analysis is one of them and has proven to be very accurate nowadays, analyzing those fields of maize and everything and coming up with the totals and all that. So it's proving to be very useful. And of course, spatial analysis has been useful since the day. And so many things, there's a lot of materials that you can read online on spatial analysis where situations have been solved using this kind of analysis. Okay. So when we talk of spatial analysis, we must not forget what we call spatial data. So there are people who call it spatial, others call it spatial. So for me, I call it spatial data. So this is basically data that has, as I said before, has location attribute. So for example, if it's a list of schools in your country, you have their coordinates, their locations on the ground. And this data represents something on the ground. So it's something that you can say that this school is based in this place, and we can actually get into a vehicle or get to a plane and get to that location. So there's a ground representation of that specific feature. And when we talk of spatial data, there are usually two broad classes or models, and that is basically vector data and raster data. Vector data, in simple terms, it's data that you can actually, it has the attributes. So it's a feature with its attributes. So for example, when you're talking about a hospital is a point on a big map. So if you are representing a city, a hospital will be a point. And that hospital has a name, it has a type, it has the capacity, it has the location, it has an address. So these are basically the attributes of this hospital. And vector data is the most used type of data that you will find out there within the industry. But it also depends with your application. If you are just dealing with analysis, the issue analysis, analyzing, maybe doing network analysis, conducting things like suitability analysis. Where do you locate a hospital? Where do you locate a government office? You'll be dealing a lot with vector data. And the vector data has 3 parts, which is basically the point, lines, and the polygons. And then raster data is one interesting form of data that is still not widely used, but it's the source. In most cases, it's the source of the vector data. So raster data, you can imagine of a satellite imagery. For example, an imagery of your city or your community. So that imagery represents everything that is on the ground. And from that imagery, you can derive hospitals, you can derive schools, you can derive roads, you can derive things like parks and all that. So raster data is basically that. And in most cases, or raster data is basically grid data. So unlike the vector data, whereby you can identify one feature and know its attributes, in the grid data, it's different. So it's being dealt with as a whole, as a grid, that is. Even a photo from your phone, it's basically raster data. You can take a photo using your phone and upload it for analysis, and you get some results. Okay. All right. So let's proceed. So so when we talk of vector data, I just wanted to show a sample. And what you can see on this image, it's basically 5 points that have been marked out on the map. And I don't know whether, can you see my cursor?
Yes, you can, Wanjohi.
Okay. So whatever you can see here, sorry, it just disappeared. Oh yeah. Whatever you can see here on the type, it says it's a feature collection. And then there's what they're calling features. So it has, it's what we call an array. So basically you'll see, this cursor is disappearing. I don't know. Yeah, you'll see that there are 5 of them. There's one that is hidden down there, but each of these represents this kind of block. So it's a feature. It doesn't have properties at the moment, but it has a coordinate for a point. So this is what we are calling vector data. And basically, as you can see, we are able to identify individual features within this data set. Okay. So within the industry, the most popular format for vector is basically what we call shapefile. And you'll be working with it once you get into this sector. Or for those who have been there, I know they've worked a lot with shapefile. There's also what we call KML, the ones that load on Google Earth. There's WKT, which is basically for those who have dealt with databases, maybe you've handled that. There's the new kid on the block called GeoPackage, which is becoming popular day by day. It's also another format that represents vector data. We have what we call raster. So raster, as I said, it's basically a grid. It's like a representation of a block of information as a whole. Yeah. So as you can see, we have Africa and part of Europe, part of Middle East shown on this image. But you cannot really differentiate between Africa and Middle East in terms of features, like the way we saw it here. Okay. So it's just one, and there's no differentiating that, because that is how this kind of data is like. And we have many formats. I just put 3. We have sorry, I repeated PNG. So PNG, TIFF, there's GIF, there are so many. There are over 20 formats of this kind of data. Okay. So if you're getting data from, say, imagery from satellites, the other day we launched Landsat 9. If you get such kind of image, it's usually in a format which is raster. And then you can carry out your analysis and your computations to get either vector data or get your results based on what you need. Okay. Okay, so the third part, we get on what we call libraries. So the topic of today is spatial data in Python. So we've seen what spatial data represents. We've seen what is spatial analysis. We've seen what is Python. So we need to know, if you wanted to work with this kind of data within Python, what kind of tools or libraries or what we call like platforms can you utilize to get or to use to carry out your analysis. So I've split it into 3 components because so Python has wide range of applications, but in some cases you'll find that someone or a developer is unable to choose between which platform or which library to use for a certain kind of implementation. Okay. So we have the first part, which is basically data processing. And for data processing, we usually look at tools that are basically able to handle computations, data conversions, issues like data abstraction and all that. So we have what we call GeoPandas. The first one is GeoPandas, and basically there's a library called Pandas, which is for data analysis or data computations. And then GeoPandas adds the geographic components to that platform. And you're able to handle both spatial and unspatial data easily, and you can actually get an output that is reliable. And then, of course, within Python, there's what we call computations or mathematical computations on data. So, for example, you are dealing with coordinates, conversions, you're dealing with projections and all that, structuring data in a certain format for use within the analysis. So there's NumPy that comes in handy. Then we have what we call SciPy. So this is for scientists. You will find most of them using this. So it's for scientific programming. There's what we call scikit-learn. I don't know how many have really seen about it. So scikit-learn is like a combination of 3 libraries in this list, which is basically the computation part, the scientific part, and the plotting part. So NumPy, SciPy, and Matplotlib. Then we have Keras, which has been existent for the last few years. So this is for guys who are doing a lot of ML or AI, so dealing with neural networks and modeling. And then we have PyTorch, which is basically by for deep learning, like what Facebook does. So Facebook uses PyTorch a lot. So you need to understand connections or networks between data. I have this person A is related to person C, has a family in person B, has, so there's that kind of, we call it deep learning. Like you're going, you're analyzing a series of layers, multiple layers of information to just derive insights from that data. And then we have PyProj, which is basically for transformations and projections. So if you're dealing with spatial data, that is something that you'll have to handle a lot. Issues like projections and transformations. And then on this part of data processing, so remember, you do not need to understand all this so that you can carry out processing. In this list, each of the libraries has a function. So it's just you to pick which function you need to use, what function you need to achieve, and use that to basically carry out your analysis. Then we have data mining part. This is one of the most interesting bits. So there's Beautiful Soup. I don't know why they called it that way, but this is what I was mentioning about web crawling. So you can decide, maybe I want to get data about a specific topic from Google or from Facebook or from Twitter. So you're able to use that to get all that information downloaded to your machine. And then if not that, then you can use what we call Scrappy. Scrappy is so what Google does on the search engine. So there's what they call crawlers and bots. So these crawl, they usually crawl different sites, get the information. So whenever you search about, for example, women in GIS, it knows that a certain website under womengis.co or .com has that piece of information that you're looking for. So you can actually do that with your own, on your own, and you can use either of the two, Beautiful Soup or Scrappy, and you'll be able to get your results. The other interesting bits, this is probably for not very technical guys, which is basically visualization. So the first two, remember, you need to do some visualization, but this part is also interesting because this is where you come up with plots, you come up with maps, you come up with graphs. So on the visualization part, there's a whole lot of libraries that you can use. So I just focused on some of the popular ones and those that are well known. So there's the IPy leaflet. This is a combination of leaflet, JavaScript library, and the Jupyter notebooks. So whenever you're using Jupyter notebook, you can use IPy leaflet to come up with interactive maps that you can use. Then we have another alternative, which is basically Folium, which you can use also for interactive maps. We have Gmap, which is basically getting popularity due to the popularity of the Google Earth Engine. So those guys who are conducting the analysis on Google Earth Engine, you are able to use Gmap and develop maps. Then we have Matplotlib, which is basically for graphs and charts. Then we have another one which is famous and robust called Bokeh. This is Bokeh goes to an extent of not only having the visualizations, but you can also come up with what we call widgets that you can actually reuse in another platform if need be. And then the last one, we have Seaborn. So we have seen Matplotlib does a lot of graphs and charts. So this is Seaborn is almost that, but now for statistical models. You know, data analysis is not the same for usual data and also for statistical data. So there are various different aspects that statisticians are looking for, and they're all that maybe for a normal analysis that someone is looking at. So it's all your choice. You can look up those that maybe you need for your work. You don't need to. I also don't use all of them, but at least I've tested most of them. You just pick the one that suits you, and you can use that for your work. Okay. So going forward, so I think that's it for the explanations between the spatial analysis, spatial data, the Python, the tools, and all that. So I want to sum it up. I want to discuss or showcase something where I used Python in our analysis, or basically a spatial analysis work that was conducted using Python. And I don't know whether it's visible or this thing is abstracting the, sorry. Can you see the topic? So it was automated household selection. So this was for a grid power distribution assessment. So in Kenya, there's a project we call Last Mile Project, where the current regime was able to distribute or to take power to the people, those reserve areas where there was no power connectivity. So they used to call it Last Mile Project. So AFDB wanted to know the success or the impact of this project. And out of that need, this part of assessment came up. And one of the things that were required is that the outputs needed to show some impacts. And by impacts, I mean positive impact, so that the bank can know, could know whether it wants to continue funding or not. So the project was carried out by an organization in Nairobi called the Advisory. I was a consultant, I was consulting for them on this project. And this is what basically we did. So I don't know, for those who have handled data or GIS projects before, there's what we usually call criteria. So someone comes to you, they tell you that I need to perform, or I need to know a suitable location where I can set up a restaurant, or where I can set up a school, or maybe a hospital. So they'll give you a series of criteria. They tell you, I don't want this hospital to be more than 2 kilometers from a road. I want it to be near a police post. I want it to be near a high populated area. I want it to be near a town. I want it to have power connectivity. I want it to have water connectivity. So whatever they are giving you is what we shall call criteria. So in this project, there was a lot of criteria that was required. And this is just whatever I've compiled here is just like a a third of what was done or a third of what was required. And the work itself, before I got as a consultant, those guys who are working as GIS technicians and experts were in a situation whereby if you are to do this process, because it was for 8 counties, if you are to perform this analysis manually, it would take maybe 3 to 4 months for them to find the data, prepare the data for analysis, analyze, come up with the assessments and all that, and then go to the ground, collect the data, and then submit the data for analysis again. So when we got in, it was just a matter of looking at the criteria, the requirements and everything. And then from that, we were now able to come up with models and scripts that would automate the entire process. So today you can run, the whole process can be done in less than an hour for the 8 counties because of the automation that is available. And it's something that was good to make the company at least deliver the project in time, because there was also the aspect of time. So just to explain in a nutshell, these processes you see listed down here are just what was some of the criteria that was given. But I'll show you what we did and the results and what was basically derived from the project. And then I think it will be a close of my presentation. So basically, in this kind of work, it involves a lot of geoprocessing, a lot of data cleaning, a lot of deciding on which tool to use for which part of the process. So if I need to know, maybe I'm told about 800 or 12,000 households per county, which tool am I gonna use? If I'm told maybe a radius of 300 meters, which tool can I use? If I'm told a radius of 1 kilometer, which tool can I use? And then this relationship must continue up to the end of the project, whereby you must give an output that basically describes what is required or what the client expects. So what we did, so the first thing I'll do, of course, was collecting the criteria, the requirements and everything. Then once that was done, then I was able to come up with models. So I developed, there were about 6 models. This is just half of it, not actually one. The full of it couldn't fit here. And as you can see, it's a chain of connections, or a chain of tools, algorithms, and outputs, inputs that basically went into these processes. So you find there's that interlinkage of one output in one process is an input in another, and the chain continues. So you might find like one model had about 60 or 70 nodes or processes that were basically doing something. And the output of that was an input in another model, and it was a chain until the end. Okay. So there are some parts that, so this was in QGIS. This is the graphical modeler in QGIS. I don't know how many maybe I've used or heard of QGIS. It's a GIS software. It's open source because I'm on Linux. That's what I use. So after the model, you are able to also convert those models into Python scripts, or you can directly code into Python. And instead of coming up with the graphical, like this user-friendly interface of the model, you can have it in code form. So there were steps that were done using this method, and there were steps that were done using the Python language directly. But eventually, everything was chained together, and it was chained at the end of the day as a Python script. So on the same note, so with this, we're also able to come up with Python scripts, 4 of them, that we are able to, because it involved a lot. It involved computing those households, like counting them, knowing which ones lay in which regions of from the transformers, what is the distance, or which transformer is related to which household, what is the distance to that transformer, and then which route from that household to the transformer can you follow on the road. Okay, so there's a lot of things that were required, and these things were acquired basically using Python. we're able to code everything. This script here, as you can see, it's just like it had more than 100 lines. These are just 20. So that was one script. And imagine there were 4. Trying to automate work that could take 4 months to take only an hour or 2. Okay. So basically, after going through that process, the output was follows. So this is a county called Kericho in Kenya. So these are whatever you can see in orange, these are households. So because you had first of all, like acquire the data for all households in that county, then whatever you can see in big dark dots, these are basically transformers, and the smaller dots are transformers, but those are that had been installed earlier. So the ones that were installed under this project were the big black dots. So we wanted to know which ones were viable for selection for analysis. And after that, we were able to achieve that only a few of them were viable based on the criteria that was given. And with those transformers, we're able to identify those households that fall within the specific regions of that transformer that was required. So an elaboration of this in the next slide, just be a continuation. So from here, whatever you, sorry, from this second slide or this second picture. So I want to zoom in out one of them to see how it looks like. And this is how they look like without the other data loaded. And as you can see in pink, we have the center points, which are basically transformers. The green parts were computed from the lines. Then we have the gray parts, we have the black dots and the orange dots, which are basically households. So the output of these, because we needed guys to go to the ground to collect the data from these households, these were the households where they could administer questionnaires. And those questionnaires were basically digital format. So we used a platform called ODK to collect the questionnaire. So by the time the person gets, the numerator gets to the ground, we already know which region they are going to and which households they are visiting. And they have that data on their platform. So they go to those specific households that have been selected by the platform. And then just to zoom in into one of them, the picture on the right, you can see there's the green line, which is basically a power line. And then you can see the orange dots, which are basically households. And then the orange lines are basically distances from that household to the nearest line. Okay, so meaning that is the line where it's connected. And then the black dots are also households in another region. So we had what we call control region and settlement region. So the settlement region was this that is marked in which color is this? I think it's okay, it's not brown, somewhere close there. So the brown region has the black dots, which are basically households, and the green region also has the orange dots, which are households. And then you have the lines and all that. So this process, Python was used, and it helped a lot because the entire process, as I said, could take a lot of time. And we had only 7 months to do the analysis, send guys to the ground on 8 counties, collect the data, come back to the office, analyze the data, and send the results to the client. So it's a bit hectic when you think of it as a manual process, and also the issue or the aspects of errors and everything. And with a situation whereby you are given criteria spanning over 50 rules that you need to take into consideration. So this is much of the things that we work on in our consultancies, trying to save people time and resources. Our organizations that basically are in need of such services. And you can see that in this case, on this project, it was a big project, and it was very influential. And of course, Python came into play, and we were able to achieve the results in a very short period. Of course, the development of everything took some while, but once it was ready, running it just took a few hours, and we were able to submit the results. Okay, so in a nutshell, I would say that so when talking about spatial analysis, as I said in the beginning, the process or the topic itself is very wide. So it depends on what you want to focus on. There are those people who probably focus on system development, like I do. You decide maybe you want to create a portal that has all amenities in the city displayed there, and then you add on top maybe some geoprocessing functionality, the searches, the filtering and everything. And then there are those people who want to maybe work on such scripts or such environments, the desktop environment to automate their work. Or there are those guys who want to go to mobile to develop some solutions that can actually be used by other organizations, by other people, and also by other teams. So basically, it's just a matter of thinking of the idea. I usually tell people that the first thing you need to understand is the problem you have. And then after you understand the problem, that's when now you decide to use Python to sort your issue. Not like trying to force Python to solve your issue. Just understand the solution first, the problem first. Once you think of how you can tackle that problem, then you can use Python to do that. Okay? And with that, I think I want to end my presentation there. Thank you very much for listening. It's only that I couldn't do some live demonstrations because of time, but probably we'll get some more time in the future. We'll be able to do some more demonstrations on that. So thank you very much. Welcome questions.
Thank you very much, Sam. That was a wonderful presentation, and there have been so much to learn from that presentation. Yeah, so we'll jump straight into the questions. Yeah, we have had so many questions, and we've also had people who say great presentation, and I agree. This was a great presentation. Yeah, so one of the questions that we have here is it very important to code to be a GIS expert? Yeah, I know that has been a discussion that has never ended. Yeah, so someone is asking, is it very important to code to be a GIS expert? And I'm just going to read another question that somehow relates to the same that was asked by Gerald Odek. Is GIS all about coding? Yeah, so I think these two, you can answer these two questions. Is GIS all about coding? And is it important? Is it very important to code to be a GIS expert? Yeah, thank you.
Okay, thank you. So to respond to that question, I'll say I don't want to give it a yes or no answer. I will say that it depends. So assuming someone told you, like, I want to see a map of vegetation cover within your country. So in that aspect, that is very easy to just go into a GIS, take the data and do the analysis, okay? But that is a very shallow level of GIS, which with time, probably like now we usually have what we call GIS technicians, experts, data analysts, and all that. So as the trend goes by, you find most people are now leaning towards code because of automation and also getting the power to carry out a certain analysis. You see, in most cases, you'll find that it's not a must, or we cannot all be coders, or we cannot all be developers. But the most important bit is the option or the power to make a decision. If today someone came to you and asked you, how can I use GIS in my transportation business? You already have ideas on what you can do with GIS or what you can do with data. So that translates to a solution, which basically this guy was looking for. So I can say you can have ideas. If you don't know how to code, you can let someone who knows how to code maybe to help you, or you work on that project together. But if you see so often you are getting the same issue that requires coding and all that, why don't you learn yourself and then be able to do those things? I usually encourage someone to always learn, because at the end of the day, you never know what the future holds. Like now, after COVID came, there are some institutions that were saying that non-essentials. So you're an employee in a company, but says you're an essential. So you're like, how? So this is basically showing those people who can add value. So can you add value to the organization? Before you even add value to the organization, can you add value to yourself? So that's the thing that I would say. Like, it's not a must everyone knows how to code, because at the end of the day, you cannot all be developers, but it's good to have the knowledge or the know-how on how to tackle issues. The second question is, can one perform the same geospatial analysis without coding and get the same result? So for this one, the specific one that I've shown you, no, that one someone had to code. Like, we try to utilize the existing tools without coding, but some of them needed some special or some complex algorithms that basically could handle the data. So for this specific one, no, but in general, spatial analysis is actually not about coding. There are solutions that exist there. So you have like ArcGIS, we have so many software for GIS that you can just use to perform your analysis. Okay. Hi, please. I like to okay. Can you perform using software such as ArcMap, commercial? Yes. So this is a question from Wijal Deka. Yeah, it's possible, because as I said, like, spatial analysis is not about coding. There are things that you can do without coding. It's very important to code to be a GIS expert. So basically, okay, I usually say, like, you can never call yourself an expert, because the industry makes you an expert. So, and as the name expert says, an expert is basically someone who can juggle between different sectors or different departments and be able to provide solutions. So coding will just be an added advantage to you. If you are young and you have the time, you can learn. If you already maybe have some years and family and all that, it's so hard to code at the moment, because the coding requires some concentration, some time, and some focus. Okay. It's about doing it. It's about doing it automated. That's what's been
There's
given.
also there was
Okay.
this question from
Then there's state of that. I'm interested.
Hi Sam.
Hi,
Yeah,
Sharon.
I'll help you with the questions. Yeah, so we had this question
Thanks.
from John Gimode, who asks, on which online platforms can one learn Python scripting? And it's the same question that Shaima Ahmed asked. Shaima was asking, please provide free online learning sources to learn Python and its libraries. Yeah, so which platforms can you recommend for someone to learn Python?
Okay. Yeah, good question. So today there are so much. There's so many resources that you can use. One, there's YouTube. So nowadays, almost like YouTube is the biggest school you can ever utilize. So if you need a topic, for example, if you go to YouTube, type maybe spatial analysis, blah, 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 you'll find a lot of videos, a lot of tutorials there. The other thing is there are these online schools like Coursera, Udemy. Some of them are providing these trainings for free. You can actually download a lot of data. You can download a lot of materials. But I think for those specific ones, more so for coding, unless you know the specific topic that you want to handle, there are those materials that if it's at course about a certain topic, you need to know that topic prior. Yeah. So if it was something like maybe data analysis using Matplotlib or maybe NumPy, you find you'll already know about NumPy, so that's why you're looking for it. So those materials are there, and there are so many of them. I think what I'll do, Sharon, I'll share a list of resources that you can share with the participants, where guys can download materials. There's so many. There are also GitHub repositories that have now stored a lot of books, a lot of guides, a lot of materials, data, and all that you can use for your analysis. So I'll share a list with you probably tomorrow, and then you can share with the participants, and they'll be able to utilize the materials.
Yeah, that's great. Maybe
okay.
just to add on that,
Yes.
Sam. Yeah. Okay, I'll speak on an open source person point of view. Like,
yes.
Well, the popular materials that maybe if you're an open source person, you do a lot of QGIS. There is Spatial Thoughts by Ujjwal Gandhi. Yeah, the Spatial
Yes.
Thoughts website has a lot of courses. Some are free. There are others that you pay, that you can learn spatial analysis. And there are also some tutorials and book by Anita Grazia on QGIS and the spatial analysis in Python. Yeah, so if you are a QGIS person, so those are some of the resources you can check. But as Sam has said, he's going to share the resources with me, and we'll share the resources with all the participants. Yeah, there is also the podcast that has been shared by Omonwala, where they did it was on resources on GIS, if you want to learn GIS and the coding and yeah, all that. So the question, there is
Okay,
this question that came in, that has just come in by Anita. Yeah, she asks, at what point exactly did you incorporate coding for automation in the power distribution project?
Okay, which question is that? At what point? Okay. At which point exactly did you incorporate coding for automation in Power? Okay, yeah. So good question. So you see, you have all this like so in terms of the data, like transformer data and everything that was basically acquired from KPLC, which is basically an organization that manages that. And then so for us, what we did, we tried to acquire the household data, which basically used one of the Facebook. There's a certain platform by Facebook where you can get all the household data for Africa. So we got all that for Kenya, and then we were able to clip it out for different counties. So at what point exactly we were able to implement the coding is when now we came to the analysis bit. We had the data we had the household data, we had the transmission lines data, we had the transformer data, but then we needed the output of that. The analysis should give us the output as I've shown you. So after the data was acquired, prepared, and cleaned out of the errors and everything, we ran that data as is into the algorithms. And then it was able to give us an output. So I can say maybe from point one of analysis, we were able to use the coding or the automation, and it gave us the results. So depending on the project, there are those projects that you can either carry out the analysis after, maybe to verify the products. But this one, because it was big and there was no time, then we from the beginning we dealt with it on the automation bit. If someone was asking whether, okay, I wonder why Python is leading in terms of spatial analysis. Then yeah, the reason as to why is there are two factors. One is the availability of the packages. You realize that R being not popular, like it has just been popular in the recent past. So find there's not so many packages or third-party libraries that you can integrate within your analysis. But for Python, those solutions have been there, they have existed, and they're widely known and used. Then the other one is that aspect of the community. Like whenever there's an issue that maybe guys or scientists are faced within the analysis part, the community is able to come together very fast, come up with a solution and deliver it as a library or as a package. So with those, of course, developers will move with the person who is up to date and the person who can provide a solution to their issues. Okay. Okay,
there is
let me
that
see.
question on what is the name of the Facebook platform where you got the household data?
Okay, I'll share before I close this, before the meeting ends. I'll find it. It's called Africa. Is it Africa Household? Okay, I can't remember the exact website, but I'll get the URL for you.
Okay, you can share with the other resources that you'll share as well. Yeah, and
yes.
yeah, as we close, there were also some people who wanted to connect with you and Joy because the project that you have done, and maybe it's something that interests them. So maybe if you can paste your LinkedIn profile on the chat so that they connect with you, or email, whichever way you prefer for connection.
Okay,
can
yeah.
paste on the chat.
This is okay, let me just paste it on the chat. So on any platform I go by the name Wanjohi Kibwe. So let me just so on Twitter, on LinkedIn, Facebook, whatever, Wanjohi Kibwe. But these are my, I hope everyone can see here. Are you able to see this slide?
Yes.
Yes, you can just email me through this. I'll be able to find the email. And also, this is my WhatsApp number or Telegram. You can always reach me via this. We also have a group, but that is basically for GeoDjango, but we also deal with matters with anything to do with GIS. That is on Telegram. It's called GeoDjango. I think what I'll do, Sharon, once I share as one email, the details and everything, then you can forward to the participants. When this, you can either text on, sorry, I don't know what's happening. You can text on WhatsApp or Telegram. I'll be reachable by this number. Okay. And for those maybe who wants to, I'm also on YouTube. So there's a channel called Life in GIS. So Life in GIS is this platform. I don't know how many of you have been able to see this. I don't know what is happening. Okay. I think that Zoom is trying to overtake my stuff. Okay. Ooh. Yeah. So there's lifeingis.com. This is the platform I was saying that we share tutorials and everything. And we also welcome guest writing. So in case you want to blog on a certain topic or to share materials on a certain project, you are welcome. We can always have you publish your articles on our platform. Okay, so I've pasted it on the chat. Okay, I hope we are done with the questions.
Yes.
Yeah, someone is asking about the YouTube. Okay, let me just share. So on so let me just share the YouTube one. Yeah, so the YouTube one is so I go still everyone on it, every platform I go by the name Wanjohi Kibwe. So sorry about that. Yeah, so this is the platform. So most of those who are doing web development, there's one popular playlist here that you'll be able to find that can really help you. It's called the GeoDjango series 1. So this covers the entire process from development, from from how you set up your project up to the end until you get some maps and data displayed on your platform. So this will maybe be a playlist of interest. You can have a look at it. And even if you are doing your project, school project or even work project, you can actually check it out. It's something that I published a while ago, but I think it has helped people out there. And it's a good resource. And in case you have questions, I'm welcoming questions, and I can help where I'm able to get the information. Shafiq is saying I'm not audible. You couldn't hear me? Hello, can you hear me?
Yeah, we heard you so well. Yeah, so okay. I think we're going to end the session. Yes. That is great, Sam, and thank you for this amazing presentation on spatial analysis in Python. Yeah, for all the attendees who attended today, we are going to share the recording as well as the presentation slides, and we're also going to share the resources that Wanjohi has promised to send. Yeah, so this was just day 1 of the 4-day webinar series. Yeah, so there is more to come tomorrow on Sunday and the last day on Monday. Yeah, so just a reminder, tomorrow Wanjoy, can you please stop sharing your screen?
Okay. Thanks.
Yeah.
Thanks. Thank you, everyone.
Okay, thank you so much, Wanjoy. Yeah, so just a reminder, we still have this. I'm sharing my screen. Yeah, let me just share my screen. Share my screen. Yeah, this one. Yeah, so just a reminder, we still have amazing sessions tomorrow. Tomorrow we'll be talking about drone technology, and also we have a presentation from Maps Geo. Yeah, I saw someone from Maps Geo talk about Maps Geo. Yeah, so the webinar sessions will be running at the same time, that is 3 p.m. GMT, and we will be using the same link to join the session. Yeah, so thank you very much, and do have a great evening, a great morning, and a great afternoon from whatever region you are joining this webinar from. Thank you and good day.
All right, bye-bye. So Sharon, I've shared the presentation on the email that was, I think, African Women at Gmail. So you find it there and share with the rest.
Okay. Bye, everyone.
Okay, bye.
Goodbye, everyone. Thanks for joining.